Hello everyone, this is Mr. O'Leary with a video on Le Chatelier's principle. So we talked about last class, we talked about equilibrium, and we were able to calculate the KEQ. So if we have KEQ for this reaction here, it would equal the products over the reactants, and in this case we have product is H2O, concentration over the reactants, which would be H2 and O2. Now remember, we have to take the coefficients and raise them to those powers, so H2 would be 2, and it would be 1, but we don't need to include that. And that's how we can calculate KEQ, or if we know KEQ, we can calculate the concentration of reactants or products, as long as we only have one variable, like normal. What Le Chatelier's principle is something we're going to use, and which is used all the time in chemistry, that's why we're going over it, is if a system at equilibrium is subjected to a stress, the equilibrium is shifted in a way that alleviates or relieves that stress. And it sounds really difficult, but it's not. It's pretty simple. There's three main stresses we're going to talk about are concentration, pressure, and temperature. And remember, we're only talking about gases. We're not going to go about solids or liquids. So if we look at this equation here, chemical reaction here, we have H2, 2H2 plus O2 gives us 2H2O. If we look at this, if we were to stress this with more concentration of H2, so we put more H2 in. There's more H2 in here, so there's more H2. There's more of a chance that that H2 will react or hit or bump into this O2 in the correct orientation to have a reaction to go forward. So because we have more of a chance, the reaction will favor the products. Now the O2, you can guess it will slightly go down because H2 goes up and it reacts with the O2, so the O2 is going to go down and it will favor the products. And similarly, if we look here, if we were to increase the O2, there's more of a chance that O2 is going to bounce or bump into the H2 with enough energy and orientation where the H2 will go down slightly and it will favor the products. So if in a simple way of me doing this, if you increase the reactants, it's going to increase the product. And it seems pretty intuitive, let's say. So if we were to increase H2O, there would be a better chance it was going to split and form H2 and O2, so it will favor the reactants. And most of the time kids don't really have, or students don't have a problem understanding that as far as increasing, but one of the things is, what happens if I decrease? If I decrease the H2O, there's less of a chance that they'll be bouncing into each other with enough energy to form H2O. So this will favor the reactants. And one of the ways I like to do it is if I put an up arrow, if I'm increasing, it flows away. So if I increase the reactants, it's going to flow towards products. If I increase products, it's going to flow towards reactants. But now if I have a down arrow, it's going to flow towards the down arrow, away from the up arrow, towards the down arrow. So that means we're going to go towards the reactants here. So if I were to say decrease the O2, it's going to flow towards the down arrow. So I'm going to go from products to reactants. And then remember, this is starting at equilibrium. So if I make these changes at equilibrium. So if we look at here, what happens if I decrease the concentration of H2O? Which way is it going to flow? It is going to flow towards the products here. And that's one of the keys that chemists use for chemical reactions is they'll have the chemical reaction go, it'll go to it'll go to equilibrium, and then you're stuck, and then that's all product you can make. But if you take product out, it'll keep going towards equilibrium, it'll shift equilibrium towards product, so if you keep taking product out, you make more product. And that's how concentration stressor. Now another one is, the next one, main stressor we'll talk about is pressure. Pressure, think about it. PV equals nRT, pressure and volume are related. So if I were to have a vessel that's like this size here, and all of a sudden I made that vessel this size, do you think there'll be more molecules in the larger area or more molecules in the smaller area? And that's what it comes down to. The pressure, as you increase pressure, it favors the fewer molecules. If you decrease pressure or increase volume like this, you favor the more molecules. So if I look on this side, I have 2H2 plus 1 O2, I have 3. I have 2H2O, I have 2. So if I have less space, more pressure, I am going to favor the side with fewer of them. So I will favor the products in this case. If I decrease the pressure, I am going to favor the side with more of them. So if I decrease the pressure, it would be more, I would favor the reactants. So it's another way we can manipulate a reaction where if I wanted more product, I could decrease the volume or increase the pressure and I would make more product. So these are very useful when we're talking about making having a reaction go forward and making more product, more of what you want. Now, one more, that the last stressor we're going to talk about is we're going to talk about temperature. So this reaction, H2 plus O2 gives us 2H2O, is an exothermic reaction. So it produces heat. So when I combine them, I combine H2 and O2, it gives off heat as H2O is formed. Now you can think of it like a match. A match has its chemical potential energy and you light it and you're taking the reactants of the match and you're igniting them or reacting them and they give off light and heat. It's the same thing with H2O. They give off heat as a product. Now if you talk about a cold pack where you put two chemicals together and they absorb energy to form a product, that would be an endothermic reaction and heat would be on the other side. So in this case, we have heat on the product side. So if we were to increase the heat, which way do you think this would flow? Think about it. What did I say? Does it flow towards or away from up arrows? So remember, if I increase this, it's going to flow towards reactants. And in the same way as if I were to decrease the heat, it would flow towards products. And this is another useful tool that chemists have. If they have an exothermic reaction and they want to increase the products, they can take heat out of the environment and it will produce products. So remember, Le Chatelier's principle is if a system is at equilibrium, is subjected to a stress, the equilibrium is shifted in a direction that relieves the stress. And our three main stressors are concentration, pressure, and temperature. Now, a major point here, and you need to remember this, our KEQ that we calculated does not change with concentration or pressure. You do not change the KEQ. So no matter what concentrations of either or pressures, if you know the KEQ is not going to change. But when you have the KEQ when it comes to temperature, it will change the KEQ. It will not be equal. It will change it. So be careful with that. You need to know that. You need to know pressure and concentration does not change our equilibrium constant, but temperature will change our equilibrium constant. So now we have a worksheet that you can practice. If you need any help or if you have any questions, just please send me an email. Thank you, stay safe, and have a good day.